Hello students, we will discuss a few numericals based on distance and displacement calculation. Let us meet at 8:30 guys, 8:30 p.m. Let's be ready.
Yeah, yes, school has started at June.
Right. These guys. So especially with the distance displacement related questions, we will see only few. I'll try to give you points. Conceptual based questions. Did you get the worksheet? Everyone? You got? You didn't get?
We also say
Okay, fine. I told you to collect it before evening. You go to office and you have to ask this in charge person, you have to get it. Okay? You will try to get tomorrow. If you ask, then only you get, otherwise you will not get. Right. So distance and displacement, few points.
any of the facts so that you watch it.
Right. Few important points about distance and displacement in motion in a straight line. Motion in a straight line. Motion in a straight line. One second, guys. Right, everyone?
Yes, sir.
Right. Motion in a straight line. This distance and displacement. Based questions and few important points. We'll just some 5 minutes. We'll recollect back the differences between distance and displacement, and few questions we'll try to discuss. Maximum 15 minutes we'll wind up. So distance, already we have discussed that. Distance is nothing but the total path length covered by a body during its journey from initial point to final point.
During a certain time.
Yes. The total path length covered is called distance. Whereas displacement is,
Final
if you can consider here, displacement is,
Final minus initial.
you can say, the shortest path length. The shortest path length between initial and final positions is called displacement. Usually the shortest path between initial and final positions or between any two points should be a straight line path. The shortest path should be straight line path. So the straight line path length is nothing but displacement magnitude. Direct, and here displacement is treated as a vector quantity. Its direction will be from always from initial point to final point. You can also express this as displacement is equal to final position minus initial position if the position vectors are given. So you can also write it as x2 vector minus x1 vector, or simply if the coordinates are given, you can write x2 minus x1 by what do you call? So x2 minus x1, not by x2 minus x1 or x2 vector minus x1 vector. If the position vectors on x-axis are given, or in general, you can write s vector is equal to r2 vector minus r1 vector if that position vector may be two-dimensional or three-dimensional, right? And you have to remember here that distance will always be positive quantity. That means if a particle started from a point, whatever may be this, whatever smaller the time interval it engages in the motion, or whatever the smaller the path length it covers, it always will be a positive quantity. This is final position. Then you have to consider that the path length should be positive always. So if the particle started its motion, then distance covered always should be having some positive value. It can never be negative or zero. Whereas here the corresponding point, you can say displacement can note down displacement can be positive, negative or zero also. Displacement can be positive, negative or zero also. Whereas distance will always be positive. It can never be negative or zero. It can never be negative or zero.
Sir, negative indicates the opposite direction, or?
Yes. That is an example we will see now.
Yes.
What does the negative displacement here means? So to understand that, let us consider one simple example. Let us say a particle has started its motion from origin. This is x-axis, this is y-axis, and this is origin. And this is positive x-axis, and let us say this is negative x-axis.
Yes, sir.
Right? The particle has started from here and traveled some 10 meters, then 20 meters, then it has traveled from here and returned its journey and traveled back to this position. It is minus 10.
Yes, sir.
Did you understand? Now, in this case, let us take this as an example. In this case, the question is, what is the distance covered and what is displacement covered? So this is the initial position. You can mark this is initial position and this is the final position.
Yes, sir.
So distance is nothing but the actual path length, the total path length. So 10 meters plus 10 meters, while returning back, discovering 10 meters plus 10 meters in 10 meters. So 20 plus 20 plus 10, 40 plus 10, 50 meters is distance. Distance is 50 meters.
Displacement will be 10.
Whereas
Minus
displacement is,
minus 10.
this is initial position, this is final position. So shortest path between initial and final position is a straight line path. If we draw a direction from initial to final position, it is along the negative x direction. So direction of displacement is along the negative x axis. So you can say displacement is equal to, the value is 10 meter, but along the negative x axis. So this can be expressed as minus 10 I cap, or 10 into minus I cap or minus 10 I cap. So here displacement is negative.
Yes, Yes, sir.
right? So whereas if the particle has traveled from here to 20-meter position, then travel back to here only, 10-meter point only. This is initial point, this is final point.
Yes, sir.
In that case, distance is 20, this is 20 plus 10, 30 meters is distance. Displacement is
10
plus 10 meters along the positive x-axis. This is 10 meters along the negative x-axis. So we can take it as a negative displacement. Here, displacement will be positive. So these examples, if you remember, you can get more clarity about this. And these points will be used in understanding next concepts called velocity and distance, velocity and speed. These are very, very important in understanding velocity and speed in natures. Okay? So these points, remember.
Yes, sir.
And from this, we can also conclude a few points that. So have a note of these points.
Yes, sir. Yes, sir.
Then I'm erasing this.
Yes, sir. Sir, in linear motion, displacement and distance will be equal, right?
That's one. Now this we are going to discuss that. Not always, in some cases. That we'll try to discuss with the help of some examples. See, let me give you one simple case. If a particle has traveled from point A to point B along this path and along this path. So this is path 1, this is path 2.
Yes, sir.
Got it? Now for path 1, the distance travelled is, if we say this is the center of a circle and its radius is, this is 1 meter and this is 1 meter. Okay? Then you can understand that distance travel and displacement travel for this path 1 both are same.
Yes, sir.
Both are same. They are equal. For the second path, distance is pi r.
Yes, sir.
If radius is 1, it is pi 3.14 meters.
Yes,
Whereas displacement is 2 meters only. So what you can understand from this example is distance will always be greater than displacement. So that means here if you consider second case, distance is greater than displacement.
Yes,
But
sir.
in first case, distance and displacement are equal. So distance will always be greater than or equal to
this one.
displacement. It can be equal to displacement. Distance can be equal to displacement, and it can greater than displacement, but it can never be less than displacement. That is another point. Got it? So that means from this you can also say the ratio of distance and displacement. Displacement. The ratio between distance and displacement will always be
Greater than or equal to 1.
greater than or equal to 1. If you take the reverse ratio, displacement by distance, less than or equal to 1. That we have to carefully understand. We are taking the ratio of distance to displacement or displacement to distance. You have to observe carefully. Right? So now, in your worksheet, already given worksheet, if you go through, you can understand few questions quickly. As I said, I will wind up in 10 minutes only. So, open concept-based questions. Already given the motion in a straight line, we have not collected that. Okay. So, write down one question. I will dictate the question. Note down. Yes. Write down. The question is the numerical ratio of displacement to distance is the numerical ratio of displacement to distance.
Which will be
Displacement to distance
less than or equal to 1.
is. I will give you the options also.
Displacement.
First option is
Sir, one small question.
Yeah, the question, I am repeating the question. The numerical ratio of displacement to distance is. Displacement to distance is. First option, always less than 1. Always less than 1. Second option, always greater than 1. Always greater than 1. Third option, always equal to 1. Always equal to 1. Fourth option, maybe less than 1 or equal to 1.
Fourth option.
Maybe less than or equal to 1. What ratio asked? Is displacement to distance. Displacement can be less than or equal. If it, instead of that, if it is distance by displacement, it should be greater than or equal to 1. Got it? Right. Next question. Location of a particle is changed. Location of a particle is changed. What can we say about displacement and distance covered by the particle? Note down the question. Location of a particle is changed. Location of a particle is changed. Let's start. What can we say about the displacement and distance? What can we say about displacement and distance covered by the particle? Covered by the particle. Options. First option. Both cannot be 0. Both cannot be 0. Second option. One of the two may be 0. One of the two may be 0. And third option is both must be 0. Both must be 0. And fourth one, both must be equal. Both must be equal.
Second option.
The question is, the location of a particle is changed. That's it. You have to carefully observe this. Changed.
Then
Means-
both must be.
Means, say for example, this is the position of a particle. This is changed. It is changed to somewhere here, or along a straight line, or in a circular path, somewhere here or somewhere here.
Most
It is changed, but it is not mentioned that changed and bring it back. It is not mentioned. Changed means it is displaced from its initial position.
Both must be equal.
Both can't be same.
Both must be equal because distance and displacement will be same at the time.
If it is changed its position from here to somewhere here,
Yes.
because it is not mentioned it is changed along a straight line or a different path. Changed.
Yes.
So if it is along a straight line, both must be equal. If it is along the circumference,
Same.
displacement should be different, the distance should be different. But they can never be 0. Right?
Yes, sir.
So, but they you cannot say they will be 0. Because it is changed, there should be some non-zero value. So both must be 0 is wrong. Both must be equal is also wrong because it is not mentioned specifically, it is changed along a straight line. Right? So,
only straight line there will be.
One of the two may be 0.
Yes,
To
sir, might
understand
be.
that,
No, sir.
No, sir.
it is mentioned that
Changed.
position is changed from initial to somewhere. It is bring back to the same means may be 0. Displacement may be 0, but this change means there should be some displacement, there should be some distance. So this also can't be correct. So both can't be 0. There will be some distance, there will be some displacement. If it is on straight line or some curved path, it may be circular path or even some triangular path, any different path. If you have an equilateral triangle, along the side of a triangle it has changed from here to here, then back to here. Somehow it is changed. That's it. So change means there will be some displacement, there should be some distance. Got it? Some value should be. They cannot be 0. Maybe displacement may be negative. There is a possibility of becoming negative, but not 0.
Yes, sir.
Right? So they cannot be 0. Both cannot be 0.
Sir, but only in straight line they'll be equal, or in other cases also there?
Only in straight line case,
If it is,
distance equal, displacement equal.
if it's in circle, half, if they move like 1/4 of a circle, will the displacement and displacement and distance will be equal, sir?
We have discussed one question. So if a particle has, this is a circular path, having, this is center, this is radius, this is also radius, right? It has traveled from here to here, traveled here to here. Then what is the distance? Actual path length. 1/4 of total circumference is distance.
Pi r by 2.
Displacement is this one. It is to understand this, you have to apply Pythagoras theorem.
Yes.
R and R means it should be root 2 R will be distance. Sorry, displacement. Distance will be
Pi r by 2.
Displacement root by r.
Yes, sir. Good.
what is that?
You are saying displacement or distance?
Distance.
Pi
Pi r by
Pi
2.
R by 2 will be distance. Right? So you have to be careful about this. So they cannot be 0. Okay? And because of the given data, cannot say that one of them can be 0. It can also cannot say. So
Both cannot
this
be.
is the only thing possible.
Yes.
Got it? So these points you keep in mind. The other question, that is in the level 2, exercise 1, we have discussed one question. That still there is some confusion, if you are confusing, so I would like to explain that once again.
Yes, sir.
And level 2, exercise 1, question number 1. Can I erase this?
Yes, sir.
With that, I will wind up. So level 2, exercise 1, question number 1. The question is, let me read the question once. Those who are not having the question, you can note down the question. The question is, a person moves 30 meter north and then 20 meter towards east and finally 30 root 2 meter in southwest direction. I am repeating this sentence again. A person moves 30 meter north and then 20 meter towards east and then 20 meters towards east and finally 30 root 2 meter in the southwest direction. 30 root 2 meter in southwest direction. The displacement of the person from the origin will be. The displacement of the person from the origin will be. So, to understand this, let us try to draw, consider the Cartesian coordinate system along the directions. Let us say this is, if you consider this is east, west, north, south, directions you have to consider. Along with this, you can also consider a Cartesian coordinate system. Let us say this is x-axis or same thing, only the simplest way. Not this direction only. Let us consider this is east, west, north, south direction. If this is, let us say, origin, from here it is started and it travels 30 meter along the north. Let us say, divide this into equal 3 parts, 10 meter, 10 meter, 10 meter. So, 10, 20, 30 meter towards north. After coming here, it travels 20 meter towards east, means in this direction. So, if you say this is 10, 20, 30 like that, 10, 20, we draw a dotted line along this. So, you can say from here it has traveled till here towards east. So, this is a 10, 20. So, in this direction, 20 meter. Then, 30 root 2 meter in southwest direction. This is southwest. So, southwest means the line exactly bisecting the angle. Actually, the angle between south and west is 90 degrees. Southwest direction will be in a direction which will be making an angle of 45 with this.
Yes, sir.
In one way of understanding that. So, in this direction it is moving means, here you have to understand, if this is 20, if you construct again a side of 20, so means this kind of a square, then a diagonal for this will give you the southwest direction for this. Some students are asked, why not you can consider this is passing through origin?
Because it's not.
Because this side length is 30, this is 20. So its diagonal will not make the angle 45 with this.
Yes, sir.
You have, why to 45 only you can ask. Why? Because it is mentioned that it is moving along the southwest direction. So that line should make an angle of 45. This is southwest direction, should make an angle of 45 with this. So in that case it cannot make an angle of 45. But in this case, if you consider this 20 and 20, then it can make. So if this is 45, then it is moving along this direction a distance of 30 root 2. But if you take this is 20, this is 20, it looks like a square. This is 20, this is 20. If it is a right angle triangle, the hypotenuse of this will be 20 root 2. But it is mentioned that it has moved a distance of 30 root 2 meters. This is 20 root 2. To make it 30 root 2, you have to add 10 root 2 more. So that you have to extend in this direction. 10 root 2. 10 root 2. Then total distance will become 30 root 2. Right? So if this is 20 root 2 means this will be 20, this will be 20. This is 10 root 2 means this will be 10, this will be 10. Right? Obviously this is already not 10. This also will be 10. But this 10 will be in negative x-axis. So this is the final position, this is the initial position. So simply you can say the displacement is from the initial to final position is in along negative x-axis. So you can say it is minus 10 meter along negative x-axis, or you can say displacement is a 10 meter along west direction. So you can say displacement is equal to 10 meter along west, or you can write displacement vector is equal to minus 10 meter. Either way you can write.
Yes, sir.
Right? So this is one of the simplest way of working out this. So why? Because the doubt of asked by one of the students is why can't we draw through this? That is the reason why. Okay? Yes, that's it. So I'm winding ahead.
Using adding all the components and getting the
That actually, when you say it is travel in y direction, positive y direction, then positive x direction, then it is moving in this direction.
that is
Right. So it is making an angle of 45 with horizontal. In such case, to add all the components, you have to resolve this component of 30 root 2 into horizontal and vertical components. So, if to resolve that, you have to draw one line here, you have to draw one line here. From here, if you draw a perpendicular line onto this, this is 30 root 2. This becomes 30 root 2 cos 45. So that will be in negative x-axis direction.
minus.
This is 20. This 30 root 2 cos 45. If you take here, 30 root 2 cos 45. Cos 45 is 1 by root 2. So this is equal to 30 root 2 by root 2. So root 2 cancel, 30 will get. So then this component will be 30 in negative x direction. This is 20. 30 means here minus 10. So that means this is parallel to this.
Yes, sir. Yes, sir.
Similarly, the perpendicular component should be same way 30. Anyway, this is 30, you know.
Yes,
This is
sir.
30. This also will be 30 means the final position should be here means along with respect to x-axis here along what is this minus 10 meter position.
So this
What
will
the
get
object
out.
understand.
Minus of that will be only 10.
Yes. Okay. So this is easy way of understanding. This will help you to understand easily. So that, right? Either both methods you can choose. Right. I'm winding this. So practice all the questions once again.